Hi, welcome to my video on solving trigonometric equations with the angle as b times theta minus h, part 3. This video will be about solving equations algebraically and a restricted domain. Notice we have a negative 360 degrees less than or equal to theta less than or equal to 180. So the angles have to be between negative 360 and 180 or equal to negative 360 and 180. Let's solve the equation. 6 sine theta equals 5 plus 1. 6 sine theta equals 6. We divide by 6, so we have sine theta equals 1. And that happens to be on the unit circle, and sine is 1, sine is the y, so this is 0, 1, so that means theta is equal to 90 degrees. Hence, theta is equal to 90 plus 360 degrees n, where n belongs to the integers, and that's all of them. So let's find the ones that fit in here. So n and 90 plus 360n. N is 0, so 90. And you put 0 in the place of n. 360 times 0 is 0, so you get a 90. You put 1 in, you get 90 plus 360 times 1. You get 90 plus 360, and that's 450. And 450 is too much, so no good. So let's, because we have negatives, let's try a negative one. Negative 1 is 90 plus 360 times negative 1. So that's 90 minus 360, and 90 minus 360 is the negative 270. And we'll try negative 2, so 90 plus 360 times negative 2, so it's 90 minus 720. That ends up to be a negative 630, and negative 630 is too far down, so that's not right. So the answer, and we start from the smallest, is negative 270 degrees and 90 degrees. These are the two angles that make this equation true. And these are the angles that lie in this restricted domain. Okay, let's try another one. And notice this one. It says solve. 0 is less than or equal to theta is less than 5 pi. That means it's in radians in terms of pi. So let's solve this equation using PEMDAS. We multiply 6 by each of these terms, so it's 6 sine theta minus 6 root 2 plus 6 equals 2 times sine theta, 2 times negative root 2, and we can subtract or put a negative 1 here. Negative 1 times these two terms are binomial is a negative 4 sine theta plus 6. And put all the signs on the left side. 6 sine theta. Move this one over, it becomes negative 2 sine theta. Bring this one over, it becomes a positive 4 sine theta. And we have a negative 2 root 2, and this is negative 6. We'll bring it over, make it a positive 6 root 2, and plus 6 and plus 6, they cancel out, or you can bring this 6 over and make it a negative, but 6 and a negative 6 gives you 0. Simplify that. 6 subtract 2 plus 4 is 8 sine theta, and they're like terms, so we can add the roots. So we get 4 root 2. And we divide by 8. So we get sine theta is 4 into 8 goes 2. So we get root 2 over 2. Root 2 over 2, that means that the reference angle for root 2 over 2 is 45 degrees. 45 degrees. I'm going to work these out in terms of degrees now first, and then change them to radians. I'll show you what I mean. So that's a special right triangle. We have 45, 45. That's a right angle. So this is 1. This is root 2, root 2. Now we have add sugar to coffee, and sine is positive. Sine is positive in 1 and 2. So let's look at quadrant 1, terminal arm, and quadrant 2, terminal arm. Reference angle is 45. Reference angle is between the terminal arm and the x-axis. So in this quadrant, theta is 45. Reference angle is between the terminal arm and the x-axis, and the rotation is this one. So theta is 180 minus 45. So theta is equal to 135. Now, I noticed I worked them out in degrees, but we want them in radians. So 45 is a pi over 4. 180 divided by 4 is 45. And 135 is 3 45s. Now, let's see, we have theta equals pi over 4 plus 2 pi n, where n belongs to the integers. We also have theta equals 3 pi over 4 plus 2 pi n, where n belongs to the integers. So now we'll find the ones that fit in here. Notice there's no negatives, so we'll say n, and we'll say pi over 4 plus 2 pi n. So we let n be 0, so we get pi over 4. Put a 0 here. 2 pi times 0 is 0. Now we'll try a 1. N is 1, so we get 2 pi over 4 plus 2 pi. N is 1, and that's pi over 4. And that's a 2, so 2, common denominator is 4, so 8 pi over 4 is 2 pi. So that's 9 pi over 4. And we'll try a 2. So we get pi over 4 plus, and we put a 2 in here. So 2 times 2 is 4, so we get 4 pi. So that's pi over 4. Common denominator is 4. And 4 times 4 is 16 pi. 16 pi divided by 4 is 4 pi. So that says 17 pi over 4. And we'll try a 3. And pi over 4 plus 3 times 2 is 6. 6 pi. But furthest we can go up as far as 5 pi. So 6 pi is too much, so that one won't do. Okay, we have these worked out, and notice we have no negative, so we don't have to try negative 1 or negative 2. So let's work on this one. So again, n, and 3 pi over 4 plus 2 pi n. Again, 0, so we put a 0 in, 0 here. 2 pi times 0 is 0, so we get 3 pi over 4. N is 1. So we get 3 pi over 4 plus n is 1, so we have 2 pi. So that's 3 pi over 4. And 2 pi here was 8 pi over 4. So that's 11 pi over 4. And we try 2. So 3 pi over 4. And a 2 going here makes 4 pi. And we're going to add, so we need a common denominator. So the 16 over pi, 16 pi over 4. So that makes it 19 pi over 4. And again, if we try a 3, we get 3 pi over 4. And a 3 will give us 6 pi. And that's too much. We're going to go as far as 5 pi. So the angles that we represent in terms of radians. So we have a 3 pi, pi over 4. 3 pi over 4. 9 pi over 4. 11 pi over 4. 17 pi over 4. Right there. And a 19 pi over 4. So we found them all in terms of a radian. Again, notice I varied the question instead of degrees, we use radians. And remember that pi is equivalent to 180 degrees. Now another one to solve. We have solve, and this one, the restricted domain is from a negative 180 degrees less than or equal to theta less than 270. And we have to solve this equation. So because we have two fractions equal, we'll cross multiply. So it's 2 times cos 3 theta minus 60. And that's 2 plus root 3 times 2 minus root 3. And remember, A over B equals C over D. Cross multiply, A times D equals B times C, and that's what I did there. Simplify that, so that's 2 cos 3 theta minus 60 degrees. And we have two binomials, so we do the FOIL first, outside, inside, last. They cancel out, and so that's 2 cos 3 theta minus 60 equals 4 minus 3 is 1, and we divide by 2, so we get cos 3 theta minus 60 equals a half. And so what we'll do here, we'll let A equal 3 times theta minus 60. So we have cos A equals a half. And we'll continue. Oops, sorry. Now we have a half, and that means, let's look for a reference angle. And we have a half, so we have this triangle where we have a 30 and a 60 and a 90. Opposite 30 is a half. Opposite 60 is root 3 over 2. Hypotenuse is 1. So the reference angle, the cos of 60, cos is adjacent, so reference angle is 60. And we look at, now we have to look and find what quadrants. Cos is positive, so we add sugar to coffee. I notice I say add sugar to coffee because it's starting the first quadrant. A lot of people use the cash rule, C-A-S-T, but you start in quadrant 4. Cos is positive, that's all, and C is for cos, so that's quadrants 1, terminal arm, and 4, terminal arm. And the reference angle is 60, so it's between the terminal arm and the x-axis. Between the terminal arm and the x-axis, put the reference angle in, and the rotation for the first quadrant. That means that A is 60 degrees, and the rotation is from the initial arm right around to here. So A is 360 minus 60. So A is 300 degrees. So we got 60 and 300. And we're working in degrees. So let's write out the first one. So we have 3 theta minus 60 equals 60 plus in degrees. So we have 360 degrees in. And n belongs to the integers. So that's, and the other one, this is 3 theta minus 60 equals 300 plus 360 degrees, and n belongs to the integers. So we'll simplify this. First we multiply by 3, so 3 times theta, 3 times 60 equals 60 degrees plus 360 n. We'll move the 180 to the right and make it a positive. Okay, and we'll simplify. 60 and 180 is 240 plus 360 n. Now we divide by 3, we get theta. Divide by 3 and we get an 80. Divide by 3 and I get 120 n. So that one is solved out. So let's work this one down. So let's take n, and we have 80 plus 120 n. So if n is 0, we could put a 0 here. That's 120 times 0 is 0, so we get an 80. We'll try 1. 80 plus 120 times 1 is 120. So that gives us 200. Try 2. We get 80 plus 2. 120 times 2 is 240. So that ends up to be 320. And we have to keep 80 is okay, 200 is okay, 320 is too large, so we can't have that one. Now, notice we have some negatives to do. So let's try negative 1. So we get 80 plus 120, negative 1. So it's 80. Oh, let's make it a minus 120. So that gives us a negative 40. And we do negative 2. So we get 120. Negative 2. So it's 80 and negative 240. So it's a negative 160. And if we go one more, we can only go down as far as 180. So, and also notice that you're dealing with 120 as the period, because the b is 3. We got a frequency of 3 between 0 and 360. So because that's a 3 into 360 is 120 degrees. So we can add on and subtract 120 from each and find it without going through the n. Now let's solve this one. So it's 3 theta plus 180 equals 300. Move the 180 over and make it positive. And it's just a matter of just taking your time and not making an error. So we add the angles up. 300 and 180 is 480, and now we divide by 3. So 180 divided by 3 is 160, and 120 n. And again, we'll do n, and we'll do this time 160 plus 120 n. So n is 0, so we get 160. N is 0, so that's a 0. We try 1, we get 160 plus 120, and is 1 times 120, 120, so that's 280, and we can only go as far as 270, so that one is, so we can't, no good to do the 2 because the 2 would be too large. And again, if you think about it, the period is 120, so 160 plus 120 is 280 without going through the end. So now let's try -1. So we get 160 plus 120 times -1, 160, make that 160 minus 120, so that's a 40 degrees. And we do -2, 120 plus 120 minus 2, 160 minus 240, and that's a -80. And if we go again, we get if we went once more, a -80 subtract 120 would be 200. So the answers, if we theta, now you put them down in order from smallest to largest. So the smallest is a -160. So tick them as you do them. The next is a -80. Done. Next is -40. And the next one is 40. We have 40, and we have a 80. And we have 160 and a 200. So notice as I picked them up, I marked them off. Now these are all the angles that lie between -180 and 270 that make this equation true. So just some more examples of restricted domains and solving the equation. Hopefully you liked the video, and if you're not a subscriber, subscribe to my channel if you wish, and visit my math website www.mathfullyexplained.com to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye bye.